Good morning, good afternoon, good evening, wherever you may be joining us around the globe. We are delighted to welcome you all to this next in the series of our Grail AI and Education event webinars, and we're delighted to have you all joining us today. We do want to mention several key individuals who have been working with Grail and support this webinar series. George Siemens, whom some of you can still see on screen, of course, and Lynn Lipsmeyer from SMU, both institutions and individuals who've supported this webinar in addition to my own university, the University of Texas at Arlington. Today, we are delighted to be joined by Dr. Emily Bender of the University of Washington, where she has been a faculty member since 2003, currently in the Department of Linguistics, and as well as an appointment in the Department of Computer Science and Engineering. Many of you know Professor Bender as being one of what I would call the true voices of analysis and critique, and one of the honest and trustworthy voices of critique in the hurricane that is AI hype. Just a bit about her that you may not have known from her Wikipedia entry, perhaps, or from our emails. She has a computational linguistics background, natural language processing background, and I say that by noting that she was a specialist in those two areas long before they were household words. She is a fellow linguist in my field, where she's also known for a wide variety of work in broad coverage precision grammars and the linguistic structures of at least half a dozen, if not a dozen languages globally. You know you've arrived in a field when you have a rule named after you. I think perhaps one of my first notices of Professor Bender was learning the Bender rule. As our field matured, frequently she would go to both in-person presentations, but also in publication settings where researchers would make grand pronouncements about language and their research without actually announcing the language or languages they were doing work in. And the Bender rule, now well known in our field, is that you state the language you are doing your research or presentation about. And as segue to her talk, many of you know that in 2021, she was instrumental in the authorship of what's an instant classic in our field, a paper that begins with the title, "On the Dangers of Stochastic Parrots. Can Large Language Models Be Too Large or Too Big?" In part due to the article itself, and in part due to the events that are associated with that article relative to her co-authors and Google and the events that made true international news and have implications to this day for us all. Emily, thank you for joining us. I'm going to pass the microphone to you. We look forward to you bringing your voice to our conversations this afternoon, and welcome again.
Thank you so much for having me and for that kind introduction. I am going to share my screen now, which apparently doesn't work unless you say I'm going to share my screen. I think it's worked. So here's the title of my presentation, and this is Euler here on my lap, who's helping/distracting. Title is ChatGPT-why, when, if ever, is synthetic text safe, appropriate, and desirable? And I hope this will be not too technical and comprehensible, and I'm hoping to save time at the end for questions. I have put the slides up online as a PDF at that bit.ly link, which will repeat on the first couple slides and then come back at the end. And my main point there is that I have a bibliography for this talk that's included in the PDF file so that you can see what it is that I'm citing if you go grab the slides. All right, so the applications of large language models, this is things like ChatGPT, seem endless. Some recent examples. So the new Meta AI demo writes racist and inaccurate scientific literature gets pulled, right? So Meta thought that they could make a information access system about science, and that didn't work. People thought they could write science fiction stories and bombarded Clarkesworld, which is a really important publishing outfit for especially up-and-coming speculative fiction writers, and it had to temporarily close submissions. You might have heard of journalists who thought they could use so-called AI to write journalistic articles. That was CNET, and that was a disaster. You might think you could use it to find out if a particular a piece of writing was actually synthetic, that is generated by one of these machines, which you can't. And there's a professor at Texas A&M who thought he could, and then accused students of having cheated using ChatGPT on the basis of what ChatGPT output when he asked it. You might think you could use it to access precedent law in legal domains. A lawyer got in trouble for trying just that. You might think you could use it to replace crisis helpline workers, as the National Eating Disorders Association tried to do, and of course had to stop because it was giving harmful advice. All right, I've done two things in these examples here. I've given you examples of the various domains that people think they're using it in. I haven't pulled any for education, but there's lots of proposals for using these things for tutors as well, which are just as ill-advised, in my opinion, as these. And then the other thing is that, of course, I've pulled the headlines that show the found out part of the story, like what happened when people tried this and it didn't go well. So my plan here is to give you a brief overview and history of the technology of language models. This is something that comes out of computational linguistics. And then go through a couple of papers of mine in this space. The first one is a paper with Alexander Kohler from 2020, where we talk about the distinction between form and meaning and show why language models don't understand. And that paper was written in 2019. So like it was already a problem and we were already on it. And then I'll talk about the Stochastic Parrots paper in the context of this race for scale. And then I have some thoughts about when you might want to use synthetic text, which is not that often, but I have some thoughts, and then a little bit about directions forward. Okay, these next few slides are probably the most technical part of this, so bear with me. What is a language model, right? ChatGPT is also known as a large language model. Well, what is a language model, let alone a large one? A better term is actually corpus model. That is, given a collection of text, we call that a corpus, that is drawn from some language, how likely is a given string of words to appear? That's the job of a language model, to model those distributional facts. This is old technology. The earliest sort of functional language models came out of the work of Claude Shannon in the 1940s, and these were n-gram language models, probably exclusively about English, speaking of the Bender rule. So a unigram language model is just what's the relative frequency of single words. Take the whole corpus, count the words, rank them by frequency. The bigram language model says, take the whole corpus, count up the sequences of two words, that is bigrams, so that we can get the relative frequency of words given one previous word. You could do trigrams where you've got two previous words and so on, longer and longer. What is this technology good for? It's things like ranking spelling correction candidates. If you remember, spell checkers in the early days just gave you the squiggle if you typed something that didn't match anything in the dictionary. And then they could say, okay, well, this word didn't match. Here's some words that it might have been that are kind of close to it. And then it could say, okay, I'm going to present those to you in order of likelihood. With a unigram, it would just be which of these is most frequent. But if it's bigram, well, given the previous word, which of these is most frequent, and so on. And now we have spell checkers that can catch when you've put a real word in that's just the wrong word for that context. So if you think about there, and there, the spell checkers that can catch when you've used the wrong one are using a language model and basically flagging, hey, this is super unlikely in this context. Language models are also good in things like automatic transcription, that is going from a spoken language signal to a written version, where the acoustic model is going to come up with a lot of hypotheses, and the language model's role is to rank them according to, okay, what's actually plausible here? They're also good similarly in machine translation, where the translation model comes up with a bunch of possibilities and the language model ranks them according to what's plausible for the target language. And language models can simplify text entry. If you remember the T9 systems, where you sent a text by typing the numbers that corresponded to the letters, but you didn't have to type, like if I wanted the L, I didn't have to hit 5 3 times. I just hit the 5 once. And if I'm spelling love, I do 5 6 8 3, and then I get the possible words that might be ranked by their probability, either in context or just absolute, depending on if it was a unigram or larger language model. Okay, so that's the old technology. We then move to something called neural language models that are built on something called neural nets, which again, actually is an old idea from the 1950s-ish. And it's important to note that despite the name, neural nets are not artificial brains and they're not artificial minds. They are collections of what's called a perceptron, which is just a mathematical function that's based on a simplified version of the 1940s understanding of neurons. And yet we have this like aura of magic around them because of these words neural and neuron. So a neural net is a collection of these math functions that takes input and maps to output. The neural language models are neural nets where the input is a sequence of words and the output at each step is a probability distribution over the vocabulary. Given what's come so far, how likely is each word to come next? So again, it's still just modeling basically the distribution statistics about words. How do words co-occur with each other? They're trained with a technique called backpropagation, where over time, sort of the training process is you start with a random initialization, and then you give it some data and compare its predictions to the actual next word in that training data. And then when they're different, adjust weights throughout the network slightly to make it a little bit more right, and do that over and over and over and over again until it comes up with a very good model of what's in its training data. They also represent words as embeddings. That is, instead of taking the word dog, and it's just like, okay, these are the characters D-O-G, the word dog is represented according to what other words co-occur with it. This is extremely helpful because it means that dog and canine and cat and maybe Fido are all sort of similar, and that helps the systems generalize. There's then been recent performance improvement through changes in the way those individual perceptrons, so little mathematical functions, are put together. So things like the long short-term memory, which is a terrible technical term because it's got long and short next to each other. That's from 1997. And then something called the transformer architecture, which is another way of putting these perceptrons together. And then also there's improvements through training paradigms. So instead, the BERT model, which came out of Google in 2017, instead of saying, okay, what's the next word, what's the next word, what's the next word, it was given a whole sentence, we're going to mask a couple of words and then try to fill those back in. So this is probably the most technical slide. You're doing good. What are these things good for? Well, they provide much smoother automatic transcription and machine translation output. They can be useful for query expansion and search. So if you put in something like best dog food as a search term, it's maybe going to expand it and find words that are kind of similar. So maybe you get food and nutrition, so you get more results back. Also good for grammar checkers, good for autocorrect, if you like autocorrect. And those word embeddings representing words in terms of what else they co-occur with gave dramatic improvements to almost every kind of language technology. Okay, so that was language model, neural language model. We talk these days about large language models. This slide's a little bit small and hard to read, but it's meant to give you a sense of the growth in these things over time. This comes from early 2021, and the blue circles talk about parameter count, so just how many of those perceptrons are in the system that's being trained, and the orange squares talk about the size of the data set in gigabytes of data. That's 2 years old now. Here's a version that somebody made in 2023 talking about now this is not data measured in gigabytes, but data measured in tokens, effectively words. How many words are in the training data? And you can see they are just getting bigger and bigger and bigger. Okay, so what are large language models good for? Well, we do see improvements in automatic transcription and machine translation, and a bunch of folks use them for what's called an end-to-end approach to many, many language technology tasks. So it might be summarization, where you take one of these large language models that has been pre-trained on the language modeling task, and then say, okay, now we're going to fine-tune that for something like summarization, where we give it texts and their summaries, and we say, okay, now do that again for this next thing. Or sentiment analysis. Is this a positive or a negative statement, and about what? People have also applied it to like taking multiple choice tests. Personally, I'm not sure why you need a machine to take multiple choice tests, but that's the kind of tasks that people have approached with this technology. Okay, we did language models, we did neural language models, we did large language models. Now we need to talk about so-called generative AI. This is a case of turning these systems that were meant for classification and ranking. So which of these sentences is the most likely transcription given an audio signal, which of these replacement words is the most likely one to be correct in context, that's classification and ranking. If you turn that inside out, instead of asking which of these strings is more plausible, you're asking what word comes next, what word comes next. And then that can be used to synthesize text. Generative AI is a cover term for all synthetic media machines. It might be generating audio, image, video, but it's the same idea. Something that was meant for classification or ranking is turned inside out to just produce something that looks plausible. This is not artificial intelligence. It is definitely not artificial general intelligence. Those terms both lack good definitions, but whatever they evoke for you, this is not it. So what is this good for? Well, now we're back to the question for my talk. When, if ever, is synthetic text safe, appropriate, and desirable? Okay, that was my history and overview of language models. Now I'm going to talk about form versus meaning. This was already an issue in 2019 with BERT. People were saying, hey, look, it understands, even though it wasn't being used to synthesize text. And so Alexander Kohler and I wrote a paper climbing towards NLU, that stands for Natural Language Understanding, on meaning, form, and understanding in the age of data. And so in that paper, we start with people talking about how great BERT is. It understands sentence relationships, they say. It does machine comprehension. It can recall factual knowledge. And all of these are overstatements. In order to talk about why something like this doesn't understand, we need definitions of meaning and understanding. So if you are encountering form in a language that you are competent in, you will easily conflate the form and the meaning. It's really hard to perceive one without the other, though I'm going to try to help you do so. In order to understand what's going on with something like ChatGPT, we need to take a closer look and separate out form and meaning. So, some definitions. Form, in the case of language, is going to be marks on a page, pixels or bytes, the movement of articulators, the resulting sound waves, the resulting visual impressions if we're talking about a signed language. Meaning, for our purposes in this paper, is the relationship between linguistic form and something external to language. And we looked at this in sort of two ways. We can talk about pairing expressions, so linguistic form, with communicative intent, what the speaker was trying to convey, or we could be looking at pairing expressions with their standing meaning. So what that sort of conventionally means that people then use in order to deduce communicative intent. So understanding then is, given an expression in a context, recover that communicative intent. Now I want to say people sometimes quote me as saying that machines can't possibly understand. By this definition, that's not true. If you have a virtual assistant and you tell it to play the radio and it turns on the radio, or you tell it to turn off the lights and it does so, in a very thin way, it has understood because it has mapped your expression to a communicative intent and taken action based on that. Now, it's not having any subjective experience of it. It's got, like I said, a really thin understanding, but technically that's understanding according to this definition. All right. There's a body of work in computational linguistics that gets called britology, which is looking at large language models, starting with BERT, and trying to understand things like, okay, what are they actually learning about language structure? What kinds of information are they using to do well on these tasks that we're supposed to be testing for understanding, but clearly aren't doing so effectively because the BERT and similar models are doing well on them? And in that context, this paper from 2020 gives a theoretical perspective on why models that are exposed only to form can never learn meaning. All right, side note here, oftentimes people compare the so-called learning done by something like a large language model to what babies do, which is a really bad comparison because what's going on with babies is entirely different. And we can find that out by looking into, well, first of all, just by being a parent, but also by looking into the child language acquisition literature. And one thing that's found is that interaction is key. If you expose a baby or a child to a language via TV or radio, and that's it, that's their only exposure, they're not going to pick it up. What interaction allows for that is so important is joint attention, where the child and the caregiver are attending to the same thing and mutually aware of this fact. And that's what allows them to bootstrap, that is the child, to bootstrap the connection between what the caregiver is clearly intending to express based on external clues and the forms that they are uttering. There's experimental evidence showing that more successful joint attention leads to faster vocabulary acquisition. And then a really key thing to keep an eye on is that meaning isn't in the form, even though we talk about it that way. There's this wonderful paper by Reddy, 1979, that sort of points out this metaphor being really pervasive in English, at least, where we talk about the meaning as conveying or containing the form. But that's actually not right. Languages are rich, dense ways of providing cues to communicative intent. And once we've learned those systems, we can use them to communicate very rapidly and even in the absence of co-situatedness, where we would have lots of other cues to meaning. So we have a thought experiment in this paper. This is why it's called the Octopus Paper. So we've got these two people, A and B. They're stranded on these desert islands, but they aren't the first people to have been stranded there. Prior occupants have established a telegraph cable beneath the sea, and A and B entertain themselves by sending messages. Well, we have O, the hyper-intelligent deep sea octopus. This is posited to be intelligent because that's not what's at issue here, who starts listening in and tracks over time the kinds of things that A and B say to each other in English encoded in Morse code. So all that the octopus has is the dots and dashes coming through. Eventually, the octopus gets mischievous or bored and cuts the cable and starts impersonating B back to A. So A types out "what a pretty sunset," and O looks at its statistics about what B has said and sends back "reminds me of lava lamps." Now, O has no idea what a lava lamp is or what remind means or even what me means, but this is the kind of sequence that B would send back in that context. And so A is satisfied. A might say, "I made a coconut catapult. Let me tell you how," and send a bunch of instructions. Well, O can't know. Its environment is different, right? So even if it had the ability to access what A was trying to convey, it's got nothing to map onto coconuts. But in this kind of context, B might say something like, "Cool idea, great job." Those are plausible sequences. O sends them back. And then, because this is a thought experiment, so we can have magically appearing bears or spherical cows, a bear shows up on A's island, and A says, "Help, I'm being chased by a bear. All I have is this stick. What should I do?" And O, this is what we got from GPT-2, by the way, sends back, "The bear is chasing me. And you're not going to get away with this," which is hilarious and not helpful. And at that point, we think that if A survives, A will realize that O is not B. All right, so what's our analysis of this thought experiment? O, despite being posited to be intelligent, did not learn to communicate successfully, and the reason is that O did not learn meaning. O only had access to forms, and meaning can't be learned by form alone because it's not there in the input signal. Learning the meaning relation, that is, that relationship between language and something outside of language, requires access to the outside world so that communicative intents can be hypothesized and tested. To the extent that A found O's utterances meaningful, it wasn't because O's utterances actually made sense, but because A could make sense of them. And that's what we're doing every time we play with ChatGPT. We are making sense of its output. All right, quick update. I think I don't have time to go through this. I've got a thought experiment involving the National Library of Thailand, which you can pick up at this URL here, that I'm going to skip over for time, but I invite you to go read that blog post. All right, let's now switch over to Stochastic Parrots. I'm going to tell you about the origin story of this paper. It started off as a Twitter DM conversation between me and Dr. Timnit Gebru, where she asked if I had written anything about the ethical considerations of large language models, or if I knew of something that someone else had written that I could recommend. And she basically had been seeing this race towards bigger and bigger in her role as an ethical AI researcher at Google, and said, you know, we should maybe be thinking about what could go wrong here. So what can I read? I wrote back and said, well, I don't have any papers like that I know of. And then a little bit later, but here's the things that I can think of that might go wrong, followed by, hey, let's maybe write a paper about this. So she looped in 4 other members of her team. I looped in my PhD student, Angelina McMillan Major, and we wrote on the dangers of stochastic parrots. Can language models be too big? And Google approved it for publication through the PubApprove process. And then while it was under peer review, someone at Google changed their mind and told Timnit, take all Googlers' names off of this or retract the paper. Don't have time to go into the full story here, but the net result of that was 2 of the co-authors ended up being fired from Google and kept their names on the paper, and 3 more took their names off. But I like to promote their work because they are wonderful researchers. Okay, so the paper asks, are ever larger language models inevitable or necessary? What are the costs associated with this research direction, and what should we consider before pursuing it? Do the field of natural language processing or the public that it serves in fact ever need these ever larger language models? If so, how can we pursue this research direction while mitigating its risks? And if not, what do we need instead? And here I'm just going to go through the what are the risks part of the paper. So the first thing we talk about were environmental costs and financial inaccessibility. And here, this is actually one of the things that this paper gets cited for the most frequently. And really, the people citing us for these observations about environmental costs should be citing the work that we cite, like Emma Struble et al.'s 2019 paper, sort of looking and saying, hey, already in 2019, this is costly enough to the environment that we should be thinking about it. And this is all focused, by the way, on carbon emissions and electricity usage, but there's been recent work talking about just how recent reporting, talking about how water intensive these data centers are too, and how that's an issue. There's mitigation efforts, so less use renewable energy, but that's still going to be a problem because we don't have unlimited renewable energy yet. So any part of that that's going to possibly unnecessary large language model training could have been used for something else. The main thing that we add in this paper to this conversation is the environmental racism angle. We note that if you're talking about a cost-benefit or risk-benefit analysis, it's worth thinking about who's getting the benefits and who's bearing the costs and the risks. And we notice that these large language models, particularly in English and other high-resource languages, are going to benefit those who have the most in society, while marginalized communities around the world are bearing the worst and first impacts of climate change. And they aren't seeing benefits from these large language models. So it's just worth keeping that in mind. There's also the issue of unmanageable training data. So you might think that the internet, as big as it is and as diverse as it is going to be representative of all of humanity. And so a training data set drawn from the internet might not be pretty, but it would at least be representative. It's actually not true on many levels. So first of all, there's a question of who has access to the internet and is contributing text to it in the first place. That's going to be younger people and those from developed countries. Who is being subject to moderation and pushed off of platforms versus who can contribute comfortably. There's interesting work on Twitter from Leslie K. Jones and also Brandeis Marshall talking about how accounts receiving death threats were more likely to be suspended than those issuing the threats. I mean, in particular, this is Black women who are being threatened and pushed off of these platforms. We then, if we're looking at the sampling, ask what parts of the internet are being scraped, because it's actually not the case that you can go somewhere and download the internet. It has to be accessed sort of piece by piece. So there's choices to be made about what to include. And a lot of this work starts with Reddit, not the text of Reddit, but the pages that are linked from Reddit. And Reddit is not representative in terms of who's using it. Wikipedia, also a common source, also not representative. And they're not going to be things like blogs, which are going to have fewer incoming outgoing links, but tend to represent, for example, the views of older people. And then finally, there's a step in training where, for good reason, the people developing the training data try to filter out pages that are primarily hate sites or pornography, but this is done with very naive methods, including lists of words that are sort of designed to filter out sites that reference sex, but then as a side effect, filter out, for example, online LGBTQ spaces where people are positively inhabiting their own identities. So at every step, we're seeing more and more skew towards a hegemonic view of the world based on how this data is collected. Another point is that, and Abeba Berhane puts this nicely, that language models are inherently conservative. Well, all machine learning is, because it takes patterns in the past to be used to affect the future. And so if we take older texts, we're going to be reifying older, less inclusive understandings. All right. One of the things that comes out of this, therefore, is bias. There's a lot of work in probing language models for bias. Blodgett et al. 2020 is a really nice critical overview of that work to 2020. Documenting this problem, as this work does, is an important first step, but it's not a solution. Automated processing steps involved in this bias work may themselves be unreliable, but also if you're going to be probing for bias, you have to know what social categories are going to be relevant. And so you need local input for your local use case before deployment. All right, so our title includes, can language models be too big? And so one of the questions is, all right, how big is too big? And our answer in the paper is too big to document is too big to use. So the solution is to budget for dataset documentation and then only collect as much data as can be documented so people at least know what it is that they're working with. Documentation allows people to understand sources of bias and potential mitigating strategies. And if there's no documentation, then there's potential for harm without recourse. And so we use this term documentation debt to talk about cases where the data sets are both undocumented and in fact too big to document post hoc. All right, risks to research trajectories. We point out that research time is a valuable resource, and all this focus on language models and achieving new SOTA, that stands for state of the art on leaderboards, particularly NLU, is probably lost research time. And in sort of everyone getting excited about this, we can ask, okay, are we actually learning something about machine language understanding, or are we really learning that these tests are just unreliable given large language models? And then, and this is what becomes much more salient in 2023, is potential harms of synthetic language. So one of the things that's at play here is we can't help ourselves but make sense of language that we see if it's in a language we're competent in. Human-human interaction is co-constructed and leads to a shared model of the world. Text generated by a language model is not grounded in any communicative intent, model of the world, or model of the reader's state of mind. But when we see it, we basically read it and make sense of it by imagining a mind behind it. We do our part of that two-sided thing, and in doing so, we have to imagine this mind. It is counterintuitive given the increasing fluency of text synthesis machines, but as we are evaluating these things and trying to understand what they do, it is imperative that we account for our predisposition to interpret locutionary artifacts, that is, bits of language that are lying around, as if they were conveying coherent meaning and coherent intent. The interpretation is on our side. So, the phrase stochastic parrots. A language model is a system for haphazardly stitching together linguistic forms from its vast training data without any reference to meaning, a stochastic parrot. Just to be clear, I'm not talking about the animal to parrot, despite all of the images on these slides. I'm talking about the English verb to parrot, which means to repeat back without understanding. Nonetheless, humans encountering synthetic text are going to make sense of it, and coherence is in the eye of the beholder. So, what are the potential harms that come from this? The stuff at the bottom of this page is sort of less connected to these points about synthetic text, though in the same region of the paper. But we were imagining things like you come across synthetic text that is repeating denigration or stereotypes or hate speech, and if you're subject to those stereotypes, or if you're the target of the hate speech, then you have the psychological experience of hearing it again. Or if it's not targeted at you, but it reinforces prejudices that you may have learned in your community, that can lead to harms to bystanders. McGuffey and Newhouse were looking at how cheap synthetic text could be used to boost extremist recruiting, where you have these message boards where it didn't really matter if the content was correct, just the point was to make it feel like there was lots of people there so that more people would join the cause. And they said, yeah, it could be useful for that. Little did we know how much people would want to be using synthetic text when we wrote this paper in 2020. The harms from synthetic text largely stem from the interaction of the ersatz fluency of these language models and the human tendency to attribute meaning to text. And this is deeply connected to the issue of accountability. So synthetic text can now enter conversations without anyone being accountable for it, which is a problem, right? Accountability is key to responsibility for truthfulness and to situating meaning, so we understand how to make sense of it, who is accountable for it, who is asserting this. And there's this lovely quote from Maggie Nelson, words change depending on who speaks them. There is no cure. But there's no who behind ChatGPT. And so we end up sort of filling that in and imagining a source for that to come from, which isn't there. Okay, update on this paper. I've been asked, how do you feel now that your predictions have come true? These weren't predictions, they were warnings. I don't feel good at all. But there's some things that we didn't predict or notice at the time. One is the extent to which there's exploitative labor practices involved in this, and there's a lot of great reporting coming out on this now. Billy Perigo in Time Magazine, Karen Howe's work through MIT Tech Review, and then more recently through the Wall Street Journal. And there was a piece, and I'm sorry I don't remember the journalist's name, but like just a couple days ago in The Guardian talking about this. We also didn't predict just how enthusiastic people would be about synthetic text, nor the extent to which it was going to be polluting the information ecosystem as it gets out there and we don't know what to trust anymore. And also the transition to treating large language models as everything machines that can apparently provide useful answers on any topic. They can't. They can provide something that takes the form of a useful answer on any topic. And Timnit Gebru and Emil Torres point out in this work from this year about how everything machines is unscoped technology. Good engineering practice says you figure out what it is you're trying to build, how you would test it, and then you build it. That's not what we've got going on here. Okay, on to use cases for synthetic text and directions forward. So again, when, if ever, is synthetic text safe, appropriate, and desirable? One of the promoted uses here, and OpenAI is promoting it this way, the fact that Bing and Google Search now both have chatbots incorporated is the same thing, suggests that information access or search would be a good use case. It is a terrible use case, all right? Large language models are designed to make stuff up. That is, they are designed to output plausible strings of text. They are not designed to compare your query to some model of the world. Arguably, if they get tuned to be wrong less of the time, they're going to become more dangerous because people are going to be more trustful of them. More importantly, and this comes from a paper I wrote with Chirag Shah in 2022, the output in this friendly but authoritative sounding voice exacerbates the problems identified by Sophia Noble in her 2018 book, Algorithms of Oppression, that sort of documents what happens when an economic imperative of advertising is threaded through our information access systems and identities like Black girls become up for sale for the highest bidder, and you get queries that return lots of porn results if you put in activities for Black girls, which is clearly not what she was looking for. That's the anecdote that she starts her book with, where it looks like either that's true about the world or it's true about what people say about the world, and neither one of those things is true. Is we have search results being shaped by the advertising economics behind the way we're doing information access now. This is going to get worse if you can't even drill down and see what the underlying pages were. And that is part of the second point here, which is that if we think we want a machine where we have an answer and it gives us we have a question, it gives us the answer, we are going to be cut off from the sense-making processes in information access, where we refine our question, we get a sense of what the possible information sources are, and we build up over time models of those different sources for ourselves. What do I think about WebMD versus Dr. Phil's website as places where I might go get information? And then also, if I encountered a new website that I hadn't seen before, how do I evaluate? If all that information is coming to us through a chatbot, basically the diversity of information sources is being masked, and we can't build up those internal understandings. All right, so that's a bad use case. What are some criteria for a good use case? All right, it has to be a situation where what matters is just language form and the content is unimportant. Doesn't matter if it's true or not. Or the content can be efficiently and effectively vetted, where before you do anything more with it, you check whether it is correct or not. The ersatz fluency and coherence are not going to be misleading. This isn't going to look like there's a person there when there isn't. And any biases or hateful content that would be problematic in your use case can be identified and filtered. And since I'm talking to an education audience, think about you've got a young child who's interacting with a chatbot, and it comes back with something that is just sort of not directly hateful, but subtly biased. For example, talking about Indigenous people as existing only in the past. How is that going to shape that child's view of the world? And what does that mean for an Indigenous child? And what does it mean for a non-Indigenous child? So we really have to be able to identify and filter problematic biases, even subtle ones. Also, originality is not required, because when these things are outputting strings of text, they are probably reflecting somebody else's ideas somewhere. It might be an idea that you don't want in the bias example, or it might be an idea that you like, and then you can't give it credit. And then finally, I've added this one for this version of the talk today, thinking about all the labor exploitation and the data theft underlying these things. A criteria for a good use case is that the LLM was created with fair labor practices and without data theft, which isn't so much what we're looking at yet. Okay, so some candidate use cases that potentially meet these criteria. Maybe a dialogue partner in a language learning scenario. You don't particularly care about the content being truthful, though you do still care about biases, right? Non-playable characters in interactive games. Again, what they say doesn't have to reflect the world necessarily, although maybe you do want them reflecting the fictional world of the game. And again, we're going to care about hateful speech and biases. Short-form writing support. So somebody who's not comfortable with formal styles can, but they are comfortable with the language in question, transform a set of bullet points into an email or into a press release, and then verify that it says what they want it to say. I think that's good so long as they really do have enough experience with the form they're targeting that they won't be like, oh, that sounds good, it sounds fancy, I'm going to send it, and then not notice that it didn't say what they wanted. And then a fourth example is a search where it's like, okay, I forget the name of this thing, or I forget the name of the movie, and you can like describe the thing you're looking for, and then the large language model comes back some of the time with the correct answer, and you can immediately verify it by searching that term in a regular search engine. That's another use case where most of the issues don't apply, although again, there's the query, the concerns about exploitative labor practices, right? And then, even if you like any of these use cases, it's worth asking, are any of these worth the environmental impact of creating and using these machines? Not necessarily. Okay. In order to make the use of text synthesis machines safe, there needs to be access to clear and thorough documentation of the training data. These are references for a variety of proposals for documentation toolkits. There was a wonderful moment of sort of scientific convergence of work starting in 2017 and published at these later dates, basically saying we need to document the source data in these pattern matching algorithms so we know what patterns are being matched. Furthermore, the software should be thoroughly tested for the intended use case and known to be of a stable version that won't change behind the scenes. If you're accessing something like ChatGPT through an API, you need to be able to know if you're accessing the same one that you tested. The use of text synthesis is clearly indicated, and that's especially for any text that's going to be published without thorough vetting. Anybody encountering it needs to be able to see this came out of a text synthesis machine, and ideally that's with a watermark that travels with it. And the accountability for content and for originality is clearly held by a person or an organization of people. I hope you're feeling like, gosh, this is really narrowing down the places where I want to use this stuff. There's not that many good use cases. Okay, quickly, directions for moving forward. At an individual level, we should be critical consumers of news about so-called AI systems and of the systems themselves. So when you're encountering some of this, you can say, okay, what's the task that this technology is meant to be used for? What are we automating? How was it evaluated in that context in particular? What data was used for system development? Does anybody know? Is the information published? Who's benefiting from automating this task? And what actions are being attributed to the technology that might be better understood as actions by people using automation? If you arm yourself with these questions and you're reading some of this hype, it can help you take it apart and understand better what's going on. At a societal level, I think we should be applying existing regulation vigorously. I like what Lena Khan is doing at the FTC. They've said, for example, there's no AI loophole. Their jurisdiction involves the actions of businesses, and it doesn't matter if businesses are using automation to do those actions. We should be insisting on transparency. We should know about the training data, what's in it, where was it taken from. We should know about the presence of synthetic media through things like watermarking. We should insist that accountability rests with people and not machines. We should insist on recourse, right? If there is a decision made by an automated system or something else goes wrong because of automation, we should have recourse and not be left with people going, well, the computer said so, can't do anything. And we should insist on labor rights, right? We should be setting things up so that people can organize and fight back against automation when it's inappropriate, and we should be not relying on technology built through exploitation. All right, that brings me to the end. My URL is at the bottom there if you didn't get the slides before and you want to get them now, and I am happy to take questions.
We have several questions that have come in on the chat. The first one
Great.
makes my linguistic heart go pitter-pat. It's about documentation. You mentioned several of the well-known toolkits. Could you talk a little bit more in detail about what is being documented? For example, data sources, amounts of data, types of data, or the specifics of training?
Yeah, really all of the above. Those documentation toolkits, so the one that I was involved in was called Data Statements for Natural Language Processing, and that's about, things like whose language is being captured here, what's the speech situation, and then what's the demographics of the speakers, what's the demographics of the annotators, if any annotation happened, what was the curation rationale, how was this set of data collected, like what was the purpose in the first place, and so on like that. But then also you could look at the model cards for model reporting, which is Meg Mitchell et al., looking at, okay, how was this evaluated for bias and various other use cases? What are sort of its range of safe use parameters? And so these toolkits are going to elicit the kind of information that should be available. One of the reasons this I think is really important right now is that people are saying, look, GPT-4 can do all these things. It has emergent capabilities. There's no information about what's in the training data. So we don't know if these things that it supposedly can do are actually directly represented in the training data or not. And so until we have that information, I think we have to assume it's got zero emergent capabilities.
Another question came in about English and other global languages. Considering that many of the LMs are trained and generate English primarily, do you think that information in English would be more heavily polluted compared to other languages? Would that cause significant impacts in terms of how we consume information?
That's a really, really interesting question. So I just put up a blog post over the weekend about an experience I had with an information ecosystem pollution event where this was image. Someone posted this picture of a really cute, supposedly baby peacock. The real word for that is peachick on Facebook. I thought, oh, that's adorable. And I shared it. And then a couple of friends wrote back really quickly saying that's fake. So I took it down. And then I went to try to find what peachicks actually look like. And that image and a couple other ones like it are in the first page of the Google image results mixed in with the real ones. And so it's just then becomes this odyssey of like, all right, how do I know it's real? And one of the things that I decided would help me settle on one of the real ones as real is that it was posted on Wikimedia Commons in 2018. So I know that it's before all this nonsense, if I believe that timestamp on it. So if you've got text synthesis happening in languages other than English, or the other sort of global, well-represented languages, it might well be that the language models are worse and less fluent seeming, and so it's a little bit easier for now to filter that out in these languages that are less well represented in the technology. So that's an interesting observation, and maybe another strategy that we can use in the meantime as we're trying to rehabilitate our information ecosystem.
As we go forward, I'll also ask folks to put additional questions in the chat. I had one about use cases on the university campus. There was an article this morning in the Chronicle of Higher Ed, I think it was Chronicle, that everybody from administrators to faculty are getting emails every day about new AI tools, use of ChatGPT, where our vendors seem to be dreaming up use cases for us or are looking for use cases. What would you say about a use case, say, at an IT help desk versus, say, one at a library, reference desk? And a third area that I've noticed several campuses are thinking about is academic advising and using chatbots in that process. And I think your facial reaction may be what's happening in my head at the moment as well.
Yeah.
About those three use cases, what do you think?
Yes, so I hate them all, but I think it's first worth differentiating between chatbots in general and LLM-driven chatbots. So everybody has encountered very rigid, narrow chatbots that have access to a range of preset answers, and you know you're talking to something that's not very flexible, and you can sometimes poke at it to get what you want. Those are not much fun, but I think they are relatively safe because their sort of domain of applicability is pretty obvious. Like what it can and can't do is clear, and they aren't going to make anything up. They've got some pre-programmed responses or the ability to point you into other documentation that a person has written, and that's fine. I think that there's still some danger there because it's still an automated system that doesn't do meaning making the way we do. And if you come in with a question where you've conceptualized something in one way and you get back its pre-programmed answer, in the pairing of those two things, things can go off the rails, but those are relatively safe. But using something like ChatGPT at an IT help desk, at a reference desk in a library, or for academic advising, it seems very risky. In the IT help desk case, what you risk is frustration of not solving the problem so quickly. So that seems like it's maybe the least risky thing, although depending on what random things you're told to try, you could end up with catastrophic data loss. So it's still not risk-free. I guess you could also end up, depending on what your IT question is, inadvertently opening a big security hole. I have a more visceral reaction to the other two, though. So, the reference desk of the library, it's like, oh my goodness, librarians are like the keepers of information and information access. And to think that that any librarians would be willing to hand that off to a machine that's going to come up with plausible sounding answers rather than, going into their expertise of how do we go find information, that's just appalling. And also sort of seems like a bigger risk to the broader information ecosystem because it seems like it's coming from a authoritative source and then people are willing to share it. And then academic counseling, again, this is like really what you need is person to person. You need the ability to understand what's going on and empathize, and it's doing none of those things. So yeah, I hate all of it.
In this era where instructors are frustrated in policing, especially, for example, AI-generated essays, what ideas might you offer your academic colleagues for how we should teach and evaluate?
Yeah. So I think the first thing is it's perfectly reasonable to create course policies that say don't use it, that this is not appropriate, and spend some time explaining to students why. And I know that there are some folks who are sort of collecting course policies across the country, and maybe broader than that even, to look at how people are reacting to it, and there's a big range. But I think having some discussion so that we are helping students level up their information literacy and say this isn't going to give you necessarily accurate information, it makes up references, it's going to be biased, it's going to be repurposing other people's ideas. These are all the reasons not to use it. On top of labor exploitation and environmental costs, which I think a lot of people of the median age, let's say at universities these days, are actually really sensitive to. So having that conversation is good. And then the other thing that I tell my students is, what I do when I am evaluating written work is I provide formative feedback. And I don't want to be wasting my time providing formative feedback on synthetic text because nobody learns from that. The point is for you to learn from my response. And then the last point is, if a student is turning to something like ChatGPT to write an essay for them, something has already gone wrong, right? Some combination of the assignment wasn't clearly worthwhile to the student, and the student doesn't have sufficient time to be working on it. And so those are the things that we really need to be addressing as those root causes.
Another question, you had mentioned educational gaming or gaming simulation, and in particular NPC. I believe I missed that acronym. As a potential use case, could you talk a little bit more about how LLMs might play a role in educational gaming?
Yeah. So NPC stands for non-playable character. I think I had it as non-player character on my slides, but it's non-playable character. What I can imagine is that it might be useful, with lots of asterisks here, if you wanted to create a virtual world where these non-playable characters are more interesting to interact with for the students. But in doing so, you have to make sure that the output isn't going to be egregious, right? We don't want these sort of biases coming in or overt hate speech. And it also needs to be set up so that clearly that character is fictional and not providing information. And I can see in the chat here that the question was, do I have particular technology I recommend? No, I that's not my bailiwick, but you'd be looking for an LLM where you know about the training data, where you know it wasn't built with exploitative labor, and where you have compared it sort of on the environmental level to what else you might use instead. Is this going to be a more profligate use of energy and water, and is it worth it?
Dr. Sevingson here at UTA has asked, what are the best ways to onboard faculty to support students in becoming more AI literate?
Oh, that's a great question. I think that, so there are some sources that I really enjoy. One is the Radical AI podcast, which is put together by a couple of PhD students in Colorado. That's pretty great. Dr. Casey Fiesler does a wonderful set of TikToks about things sort of in the AI ethics space. Another podcast is Tech Won't Save Us by Paris Marx. I think between Tech Won't Save Us and Radical AI, there's some good, very down-to-earth sort of understanding of what's going on. I'll put in a plug for my own podcast, which is Mystery AI Hype Theater 3000, together with Dr. Alex Hanna. And that's very snarky. And we are sort of cutting through AI hype. So, sources like that. And other places like the reason I'm giving this talk is that it's part of my mission to help people better understand what's going on with AI. And so if you go to my web page, my faculty page, I have a media page where you can see all the stuff that I'm doing that's public facing work. And hopefully some of that will be useful as well. In terms of actual curricula for raising AI literacy, the only thing that I have to hand is Radical AI actually put together a curriculum based on their podcast episodes. But I think that that's more focused on like ethical development of technology rather than like for a layperson understanding hype and cutting through it. Hopefully some of that's helpful.
Perfect. Thank you to Ron Lethko. I see he's unpacked the bit.ly and also given us links to Mystery AI Hype Theater. I would add one more question before we run out of time. We still have 2 more minutes. What would you say to the researchers who are attempting to bring the structured knowledge world, the knowledge graph people, and join them to the large language model world? At least on the surface, perhaps thinking about the grounding problem. What would be your thoughts on that sort of research angle?
So I guess my thoughts would be if it's marketed as building general purpose AI, I'm very skeptical. If it's marketed as building specific technology for specific use cases based on known human crafted data sets that can be tested in its use case, then it seems like it might be a plausible direction to go. I would still be skeptical of using the language models for text synthesis rather than something like query expansion, just because they can mess things up in subtle and hard to detect ways because they sound so fluent. And all of the questions about environmental impact and labor exploitation still apply. But if you think sort of on a smaller scale and focused on specific use cases, it could be a promising direction.
And with that, the clock just struck 4 o'clock here in Central Texas. So thank you all for joining us. And please join me in thanking Dr. Bender for her insightful work and words today, and we look forward to following her in all of these directions that she spoke about today as well. And I see the clapping hands and other icons are beginning to flow. So yes. Thank you, Dr. Bender.
That's really fun. Thank you so much for having me, and thank you all for your attention.
Thank you all for coming. We look forward to seeing all of you at a future Grail event and continuing our discussions as we go forward. And thank you again.